we define the divergence of the vector function f of x, y, z equal to pi plus qj plus rk, where p, q, and r are implicitly functions of x, y, and z, as del dot f, del being the del operator, partial with respect to x, I, plus partial with respect to y, j, plus partial with respect to z, k, that dotted with the f function. And the dot product then is very simple. This partial with respect to xi dotted with pi is partial with respect to x of p. And similarly, the j with the j gives us partial with respect to y of q, the k with the k, partial with respect to z of r. And of course, I dot j and I dot k are 0. J dot I and J dot K are 0. K dot I and K dot J is 0. So this is all we get. And that could also be written as P sub x plus Q sub y plus R sub z. The curl is the cross product of this del operator with the function. Now, if this was a cross here, then I'd have to do the I cross I. Well, that's 0. I'd have to do the I cross j. Well, I cross j is k. So I'm going to have a partial with respect to x of q, and that's q sub x, and that'll be multiplied by k. A partial with respect, well, the I with the k, well, I cross k is negative j. So we're going to have partial with respect to x of r, but it's going to be a negative k. So we have negative j, I'm sorry, rx, negative rx times j. Well, we just go through all these possible products, or we write it out as a determinant, which everybody does, and we get exactly the same thing. That's your del cross f. Now, the reason it's equal to this is because of the distributive law and the way i's and j's and k's have their cross products. Coincidentally, and not so much really a coincidence, but it turns out that the determinant notation gives you the same result. The idea of curl, which is this, is that if a field is radial near a point, okay, then there's no curl, okay? And also that you have a non-zero divergence. Now, curl is a measure of the rotation of the field. If the field looks like this, then it clearly looks like it's rotating about the point, right? So there's a net rotation here, but there's no rotation here. The other thing is, it turns out that you have a non-zero divergence when you have this. That is that your del dot f won't be 0 at this point. If the field circulates around a point, I say rotates, circulates probably would have been a better word, that implies that at the point your divergence is 0 and your curl is not. Just a little bit of intuitive connection to the ideas of divergence and curl, and of course we're going to be developing those in much more detail.